When NVIDIA unveiled the Blackwell architecture, the industry went into overdrive. Demand is so intense that the entire product line is sold out for 12 full months. But what's behind all the hype? Why do experts call Blackwell NVIDIA's most ambitious project since CUDA? And most importantly, how will it change the world of artificial intelligence, starting today? Let's find out. The history of NVIDIA architectures is a story of exponential growth. Ampere gave us massive scalability. Hopper introduced the transformer engine. But Blackwell is something else entirely, a fundamental shift. This is not just another generation of chips. It is a complete rethinking of how we approach a computation. Systems built on Blackwell, such as the DGX, deliver 3 times the training performance and 15 times the inference performance compared to the previous generation. Numbers that once sounded like science fiction are now reality. At its core are several key innovations. First, 5th generation link, with an aggregated bandwidth of 14.4 terabits per second. Second, memory delivering 64 terabits per second of bandwidth. Third, support for precision, which fundamentally changes the economics of inference, and here is the key takeaway. Inference cost on Blackwell is approximately 2 cents per 1 million tokens, that is 4.5 times cheaper than on Hopper. The flagship data center solution is the DGX platform, a unified platform covering the entire model development and deployment lifecycle. Let us look at the specifications. NVIDIA Blackwell bus onboard total memory 1440 gigabits of performance, 144 petaflops for inference power consumption, approximately 14.3 kilowatts and 112 Intel Core price starting at $515,410 US. Notice the link speed 14.4 terabits per second of aggregated bandwidth. This allows all 8 cores to work as a single unified superprocessor, and this is not just hardware. The DGX ships with the full NVIDIA enterprise software stack and mission control for infrastructure orchestration, but the most impressive part is the real-world use cases. Notice the link speed 14.4 terabits per second of aggregated bandwidth. This allows all 8 cores to work as a single unified superprocessor, and this is not just hardware. The DGX ships with the full NVIDIA enterprise software stack and mission control for infrastructure orchestration, but the most impressive part is the real-world use cases. The Mayo Clinic deployed a DGX superpod based on to develop foundation models for healthcare. The result: processing pathology slides that used to take 4 full weeks now takes just 1. And that is only the beginning. But NVIDIA does not stop at data centers. The company is bringing Blackwell's power straight to your desktop. The DGX Spark is a miniature supercomputer, about the size of a nut, that fits right on your desk. At its heart is the Grace Blackwell superchip, developed together with MediaTek. 20 ARM.2 cores, 10 Cortex-6 plus 10 Cortex, 128 GB of unified DGX memory, up to 1 petaflop of performance, 4 TB NUM, 273 GB per second of bandwidth. This little machine can run models with up to 200 billion parameters locally. And if you connect 2 units via the built-in connect, you can scale up to 405 billion parameters. Originally priced at around $3,000 US, the unit has climbed to $4,699 due to global memory shortages. Even so, it is still a revolutionary tool for developers, researchers and data scientists. And this is the DGX Station. It is no longer a mini, but a full-fledged workstation built on Grace Blackwell Ultra. The numbers here are seriously impressive. 72-core Grace boost 148 gigabits of unified memory, up to 20 petaflops of performance support for models with up to 1 trillion parameters. And here is the key announcement. NVIDIA is releasing a Windows version of the DGX Station. This is the first system to bring Grace Blackwell level infrastructure directly into the Windows ecosystem. DGX Station for Windows lets you run AI agents right inside your familiar workflows. No need to switch to Linux. No dependency on cloud providers. All of Blackwell's power, available locally. Network speeds reach 800 gigabits per second, allowing you to link multiple stations together to scale your workload even further. Blackwell is not just a new architecture. It is a bridge between cloud computing and on-premise solutions, between data centers at the OpenAI scale and an engineer's personal workstation. It has changed every layer of the computing stack. Jensen Hu NVIDIA is building an infrastructure where AI becomes accessible to every developer, every researcher, and every business. Where training large models is no longer the exclusive domain of corporations with multi-billion-dollar budgets. We are standing at the threshold of a new computing era, and Blackwell is the key that unlocks that door. What do you think? Will Blackwell truly democratize AI? Or is this just another step in an ongoing arms race? Drop your thoughts in the comments, hit that like button, and I will see you in the next one.